World Spaceflight News Special Report.
Coverage of the tanking of NASA's moon rocket called the Space Launch System, which you see right there on Launch Complex 39B. The Space Launch System is ready for tanking ahead of a planned launch attempt at 2:17 p.m. Eastern Time. I'm NASA commentator Derrol Nail, and I'm coming to you live from inside Firing Room 1 at the historic Launch Control Center, where Apollo and the Space Shuttle were launched. We also have close to 91 launch system engineers here with Exploration Ground Systems. They are currently configuring the Space Launch System and Orion spacecraft for a flight test around the moon. And they are led by Launch Director Charlie Blackwell-Thompson today, NASA's first female launch director. We are currently holding at T-minus 6 hours and 40 minutes. But when you add the pre-planned holds, looks like we're just about an hour and a half or 8.5 hours until liftoff. Get you caught up on all the things that happened early this morning. At 5:35 a.m. Eastern Time, just about 10 minutes ago, Launch Director Charlie Blackwell-Thompson gave her team the go for tanking of cryogenic propellants. And so right now, the launch team is configuring the core stage liquid oxygen and liquid hydrogen lines that run from the cryospheres at Launch Complex 39 to through 1,500 feet of vacuum-jacketed lines to the mobile launch platform and into the rocket. It is a dynamic process, and we will be tracking it the whole way and providing you with updates on the major milestones as they happen. We got a weather brief this morning as part of the mission management team meeting that met with the contractors and program leadership to get a go on moving forward with tanking. And they met just about right around 4:45 a.m. this morning Eastern Time. In that meeting, we got a weather update from Launch Weather Officer Mark Berger. And he said we are green on weather for tanking. Given a little bit of a radar summary as we look out on the radar, we don't have the shot, but you can see we've had the lens cleaned a little bit after some rain on the first attempt on Monday. Currently, the ocean is a bit lit up with showers, even a few storms. Got a little bit of lightning over warmer waters of the Gulf Stream, but it's not holding together that well. The LWO says that it will push closer to us, could get some showers, but the chance of lightning is low. Of course, they will be monitoring that closely. Overall, 10% chance of lightning within 5 nautical miles of the pad. That is the constraint to tanking, and we are below that. The constraint, is 20%, and we are currently at 10% chance of lightning, and that's the big constraint. So that's good news. The modeling that the weather officer is looking at shows a lot of showers to the north of us around the Jacksonville area. He said he expects the right around 11 a.m. the sea breeze to start organizing, and it'll fire up some storms right over Kennedy as well, but expects as we get towards the time to launch, closer to 2 p.m., those storms should get nudged west starting about late morning, early afternoon. And then right at 2 p.m., we should have some storms to the west of Kennedy, forced to the west by the sea breeze. And that's good news, because once they form, if that onshore flow keeps pushing, it should push it over and cause storms over in the Orlando and Tampa area, which is well to our west. The concerns and the constraints officially from the LWO are flight through precipitation, cumulus cloud rules. Those are the two ones that we are watching today when it comes to launch time, the T0 at 2:17 p.m. Eastern Time. So for that window, we've got a 2-hour window to launch that runs to 4:17 p.m. Eastern Time. And the probability of go is 60% in the early part of the window, and then improves to 80% in the second hour of the window. The backup day is on Monday. The probability of violation is 30%, meaning 70% go. And then Tuesday, if the team doesn't get started with tanking and there's a weather delay, should it come to Tuesday, it would be a 50 to 60% go, with a concern about cumulus electric field, anvil cloud for both, and this is because of the later T0 time for both of those. Winds are not a factor, just about 8 to 12 knots, well below the constraint for today, and winds aloft, fairly weak as well, which is expected for this time of year according to the LWO. Let's review what happened since our last launch attempt 5 days ago on August 29th. Launch teams have updated procedures, practiced operations, and refined their timelines. Exploration Ground Systems technicians fixed a leak on the tail service mast umbilical by replacing a flex hose and a loose pressure sensor line, which is likely the source of the leak. They also tightened bolts surrounding the enclosure to ensure a tight seal so that when super cold propellants run through the lines, they hold that seal. And you're looking at the engine section of the Space Launch System, the 4 RS-25s in the center, the 2 solid rocket boosters to either side. The launch team will use different procedures to chill down the RS-25 engines that you're looking at today. Part of that is the kickstart bleed test, which they will test earlier in the countdown during the liquid hydrogen fast fill phase for the core stage that's expected to be around 8 a.m. Eastern. And of course, we'll track that for you. This will allow additional time to cool the engines to the appropriate temperatures for launch. It will use more propellant, but the launch director says she has enough margin to get through today's 2-hour window. This is the first integrated test of NASA's Space Launch System and Orion. Shot right there, that is the intertank umbilical, which carries the liquid hydrogen vent line and the gaseous nitrogen supply, which that is important and is in use right now, pumping into the vehicle, clearing out any cavities prior to cryoloading. The Space Launch System in Orion at the top is the first human-rated spacecraft to go beyond the moon in 50 years. And we're excited to get started. And so we'll track tanking. You'll hear me come on when mission milestones are reached, or if there's any problem, we'll talk you through it. Previously, there's been a fair amount of work for the team getting ready for this moment. Launch controllers have powered on the different rocket systems and spacecraft systems. And that's a lot because, as you can see here, this is one big rocket, 322 feet tall. This is the Block 1B Space Launch System. The mobile launch tower then rises another 20 feet or so beyond that. The total height from the ground, including the mobile launch tower, the rocket, the launch tower itself, 370 feet tall total height, well above the Statue of Liberty in New York City. You see across the bottom, we have 4 major milestones to tanking: the preparation, core stage LOX loading, core stage LH2 loading, and ICPS tanking. At various times, the launch team communicates various things that they're looking at and working, and I may pause to catch some of that discussion and then pass it right along. So let's get started. We're currently at T-minus 6 hours, 40 minutes, and holding. This is Artemis Launch Control. And we just received a go for core stage loading operations. Again, we are go for core stage cryo loading operations. Liquid oxygen transfer line is now in chill down. The liquid oxygen transfer line is now in chill down. We are go to proceed with core stage loading operations. Go for liquid oxygen core stage operations. Again, go for liquid oxygen loading into the core stage. As part of the new operations, they are also beginning to transfer a little bit of liquid hydrogen in the line. That's part of the chill down process. So both the LOX transfer line chill down and the liquid hydrogen line chill down are in work. Again, both LH2 and LOX transfer line chill down is in work. Propellant for the main engines of the Space Launch System, the RS-25s made by Aerojet Rocketdyne. Hydrogen is the lightest element known to humans. In its natural state, it is a gas, but for propellant, the hydrogen is cooled to a temperature of minus 423 degrees Fahrenheit. The liquid hydrogen comes from a cryosphere, a large spherical holding tank that is 1,500 feet away from the pad. The capacity of that tank is 850,000 gallons. The Exploration Ground Systems here at the Kennedy Space Center is currently having that tank upgraded, not the exact tank, they're actually building a new tank, I should say, a new cryosphere, and that one will hold 1.25 million gallons, % increase in capacity. That's important for the SLS program. The previous cryosphere supported the Saturn V rocket and the space shuttle. But in this case, for the SLS, the liquid hydrogen tank is 537,000 gallons of liquid hydrogen, the largest cryo tanks in a core stage or booster stage in the world. And so there'll have to be a significant more capacity in order to do a quicker turnaround after a scrub. In the case that a launch is called off and tanking has begun, new commodities have to be taken. They have to replenish the liquid hydrogen. They have to replenish the liquid oxygen. But the liquid hydrogen tank, because of its current capacity, that replenishment takes a couple of days. So there's a minimum of a 48-hour turnaround to get that cryosphere replenished. Hoping to have the new cryosphere online and operational in time for Artemis II. If you followed our launch attempt on Monday, then you know that the liquid hydrogen loading started after they got started with liquid oxygen. But in this case, the liquid hydrogen ground slow fill is in work. That is part of the new process to chill down the upper stage piping and the liquid hydrogen separator. Getting everything on the liquid hydrogen started early. And the shot you see here with the core stage in the middle and the boosters on either side, those two lines coming out, one of them is the liquid hydrogen vent line. And so as the liquid hydrogen goes in, that tank is currently at ambient temperature, which at last check was 80 degrees in the warm Florida air. So when that, when eventually that minus 423 hydrogen goes in there, it will vent out that line that's carried in the umbilical, and that will then go out to a flare stack and be burned off. You can see it sometimes at night if it's burning some impurities. Hydrogen itself you can't actually see burning. The team doesn't vent liquid or gaseous hydrogen straight out into the air. They burn it off as it's vented out of the vehicle right there at that location that you're looking at. T-minus 6 hours and 40 minutes and counting. T-minus 6 hours, 40 minutes, I'm sorry, and holding. I want to give you an update on the core stage liquid oxygen tanking. Just a few minutes ago, the chill down of the lines that run from the cryosphere to the rocket has been completed, and now they are in main propulsion system chill down. What they do here is they allow a little propellant to flow into the lines and then into the main propulsion system, which is the plumbing essentially that goes to the engine. You have three major components here. You have the tank, you have the main propulsion system, and then you have the engines. All of them have to be chilled down to the proper temperature. The main propulsion system is basically the plumbing between the tank and the engines. And so they allow a little bit of liquid oxygen to naturally go into the line. No pumping at this point, but a little propellant flows. It flashes off quickly, so once it hits that ambient air, the cold gas that results is enough to then go through and chill down the lines so that when the super chilled liquid propellant is pumped through, it's not a shock to the system. For the main propulsion system chill down, they're getting the pumps running and just getting that gas in there to help condition the system so that it, as I mentioned, it can handle the liquid. Up next will be the announcement of core stage liquid oxygen slow fill. That's coming up. This is Artemis Launch Control. T-minus 6 hours, 40 minutes, and holding. Have an update on the liquid hydrogen flow. Stand by. The launch team discussing a couple of issues, so please stand by. We have stop flow in both the liquid oxygen and liquid hydrogen. So over on the liquid hydrogen line, there was an overpressure warning. This is part of the vent line chill down, so midway through the rocket, we have a shot of this one actually. No damage to the hardware. The system automatically put the hydrogen in stop flow. And they're currently working a manual configuration to get the vent line going again. And since this started about 8 minutes ago, the team has resumed flow through that vent line, which heads out to the separator in the flare stack. So overpressure, alarm went off, no damage, system automatically put into stop flow, and they've got it going again. Let's go over to the liquid oxygen side. They had chilled down the lines. They were in drain back. There was a pressure measurement reading as well, and so they backed off the pumps for the moment, but looking to reactivate those pumps here shortly. They notified the NASA test director about this. Launch director is aware. Team is working. We'll give you an update in just a bit. This is Artemis Launch Control. I want to give you an update on the clock. Looking a little forward in the countdown. Currently at T-minus 6 hours and 40 minutes. The Resumption of the countdown clock will happen at roughly 7:07 a.m. Eastern Time. Again, we will resume out of what is a pre-planned 2.5-hour hold that we're currently in, all planned. The cryo-loading operation moved back and to the left, and so now it's earlier into the hold. That wasn't the original intention when they drew up the plans, but through the wet dresses and launch attempt. And stand by. Okay, the what they call the CLOX team, the liquid oxygen team, discussing with the NASA test director and the launch director the stop flow that happened on the liquid oxygen side. They've got the pump repressurized, it's putting pressure into the line, stable, and liquid oxygen is flowing back to the vehicle. Minimal impact to the timeline. Flow rate, no impact to the flow rate going forward. I think it might have had to do with the tank being at a high liquid level once it was refilled after the first launch attempt. So all good there. Over on the liquid hydrogen side, still awaiting an update on the recovery plan there. Just to recap, that went into a stop flow. But the team is manually bringing it back into the configuration to get moving again. And we'll look for more updates in a moment. We are close to sunrise here on the east coast of Florida. Light begins to illuminate the background, as you can't see from this shot, but we've got some clouds offshore. Weather team is watching, as you can see from this shot, the light that's starting to fill the sky. We're at twilight. T0 at 2:17 p.m. Eastern Time. We are currently in the cryo-loading operations, loading both the liquid oxygen and liquid hydrogen tanks. Had a couple bumps in the road. Team is dealing with those. Core stage liquid oxygen, starting to flow that back down the lines from the cryosphere to the rocket. Starting to get a little bit of venting down in the engine section from that super chilled liquid oxygen. Goes into the tank and almost immediately, even in fact down the line, it's in a boiling state, pushing gas out in front of it, and so they vent the gaseous oxygen through the engine bay as well as the top of the tank. And once we get a little bit more flow in there, a little bit higher liquid oxygen level, we'll start to see the venting midway up the rocket. This is Artemis Launch Control. Update on the liquid oxygen loading side of things. Just got an announcement that the main propulsion system chill down is complete and LOX is in slow fill. Again, the main propulsion system, the plumbing between the tank and the engine, that is in chill down, and now we are in slow fill. Update on the liquid hydrogen tanking now, with the overpressure issue resolved. The liquid hydrogen team just got the go to perform slow fill for liquid hydrogen. Again, they just got the go to begin slow fill for liquid hydrogen. We are going to be picking up the countdown clock. You see it holding now at T-minus 6 hours and 40 minutes. We're going to be picking up the count in just a few minutes. We reached a standby. Countdown clock will resume right now. So we have the countdown clock moving, as you can see on your screen, at 7:07 a.m. Eastern Time. We got an update on the core stage liquid oxygen loading. They are now in fast fill. Again, the core stage liquid oxygen, the LOX, is now in fast fill. The pump speed for fast fill, about 2.5 times faster than slow fill. Stand by. As we stand by. As you're looking at this view right now, this is engineering camera 814 going through a scan of the core stage tank. If you've been following the operation, and you know that we had some cracks develop in the thermal protection system. That's that spray-on foam. That's a rusty brownish color. And so what this particular engineer is doing right now is taking a close look at the tank, and this will happen throughout the tanking operation. Some cracks were discovered when we got the tank filled during the first launch attempt. Some of the cracks, when the tank gets super chilled, can have a cryopumping, something that's called cryopumping, where air is literally pulled into the crevice, super chilled, frost develops, and then it creates a vapor trail. It can appear like a leak, but it's actually not. They're very familiar with these cracks, especially the engineers going back to the space shuttle program, where the external tank, which had the same thermal protection system, have a lot of familiarity with how it responds when cryogenic temperatures are reached on the inside of the tank. You can see at the bottom there, stand by. At T-minus 6 hours, 34 minutes and counting. Stand by. Getting an update on the liquid hydrogen. The team talking to the NASA test director right now. Once that's complete, we'll have an update, so stand by. 7:15 a.m. Eastern Time here at the Kennedy Space Center in Florida. Got an update on the liquid hydrogen loading. They are in stop flow at the moment. There was a leak detected in the engine cavity. Went up to 8%. That put it in automatic revert for the liquid hydrogen flow. Rocket's in a safe configuration. Looking at the path forward. The team is going to let the area where the leak is coming from, which is a quick disconnect, I'm going to let it warm up. It should take about 30 minutes. So we're going to put them a little behind on the hydrogen timeline. And the hope is that it'll warm up that QD, and once they hit it with cryos again, hoping to reseat that quick disconnect. The leak is in the plate cavity around the quick disconnect, indicating that there is a QD seal leak. This is not the same as last time. Want to note that. Again, not the same QD as the previous hydrogen leak. This one has been tight in 5 previous flows. So the team is working that pre-plan right now, and we'll of course keep you apprised. Just to overview, core stage liquid oxygen is flowing, but the team has reported that they will adjust their pump speed because the core stage liquid oxygen levels are supposed to be kept at a specific proportion to the liquid hydrogen. It's called the aft strut constraint. And it basically says that you can't be above 50% liquid oxygen until they have at least 5% liquid hydrogen in the tank. That is because when super chilled propellants, liquid hydrogen and oxygen, go into this core stage, it can shrink the vehicle very minimally, extremely small, but that affects the struts, which are connected to the solid rocket boosters. It can actually, the movement of the core stage must be in proportion all the way along the vehicle in its connection points at the aft strut. You can see the aft strut if we take a look at the bottom of the engine section. So again, core stage liquid oxygen team saying they're going to slow their pumps a bit. They were in slow fill as of 7 a.m. And there you see a shot of the engine bay there. And the aft struts. You can see those. They are the silver colored connection points where they are attached to the core stage. They attach the core stage and the solid rocket boosters. You have the solid rocket boosters on either side. They are not affected by temperature, but the core stage is. And so they want that aluminum core stage shrinking at the same rate at the top and the bottom when they load propellants. So again, the liquid hydrogen team in stop flow, working a leak in the engine section. Stay tuned for more updates. This is Artemis Launch Control. Getting an update now from the liquid hydrogen team. They're about to update the NASA test director on a plan. Currently, we are in stop flow for liquid hydrogen. Team is working that. They detected a leak down in the engine section. Stand by. And until that conversation starts, I'll update you now again. Leak detected right there in the engine section of the core stage on the liquid hydrogen side. So 15 minutes ago, liquid hydrogen was flowing, went into stop flow after a sensor there detected a higher than normal percentage of gaseous hydrogen, which is the indicator for a leak. Leak located in an area in a basically the can around the QD. The leak is in the plate cavity, indicating it's a QD seal leak. So now the liquid hydrogen team is working a plan forward to reinitiate the flow of liquid hydrogen. Meanwhile, liquid oxygen is flowing at a little slower rate. We've got a graphic that's tracking that in the core stage. The liquid oxygen tank is above the liquid hydrogen tank. It's 196,000 gallons. As you see there, looking on the left-hand side, you can see that we are in fill. The tank, again, above the 537,000 gallon liquid hydrogen tank. You can see the fill rate and where that is on the rocket. Temperature, minus 294 degrees. Currently 15% filled. Now, the LOX team will have to has slowed their pumps down while the hydrogen team is working an issue. They can't get that number above 50% before hydrogen is above 5%. It's called the aft strut constraint. Stand by, getting an update now. (7:44 p.m. Eastern Time). Currently T-minus 6 hours, 2 minutes and counting. With an update on the liquid hydrogen leak that the team saw about a half hour ago. They're working a plan, getting ready to put a plan into effect here in 1 minute. They are going to manually warm up the liquid hydrogen line, which is connected on the other side of this core stage. The shot you're looking at, you see where that checkerboard target is. That's a target that's put there so that the flight tracking cameras can understand the orientation of the vehicle in flight. You see it on the core stage, the boosters on the side as well. At any rate, right where that checkerboard is, on the other side of the vehicle is where the umbilicals connect the supply side for liquid hydrogen and oxygen. And there's a plate, an interface that goes from the ground side to another plate on the vehicle side, on the inside, and there's a cavity between those two. And they got a spike in hydrogen readings that caused an alarm to go off and stopped the flow of liquid hydrogen about 30 minutes ago. There's a cavity that's formed between the two plates on the flight side and the ground side. Stand by. That was an update just now from the liquid hydrogen team letting the NASA test director know they're getting ready to perform this manual fill and manual chill down, I should say, of that quick disconnect where they suspect the leak is. So they've been warming up that connection. After they stopped float it at 7:15 a.m., they've been warming it for the past half hour, allowing that to warm up. According to the cryo guys, the cryo team, they say that allows it to reseat once they re-hit it with, and slowly, chilled liquid hydrogen. That gas gets in there, and that slow change in temperature, they're hopeful that they can reseat that 8-inch QD liquid hydrogen supply line. That's the one they currently suspect is leaking. We're going to get an update from the hydrogen team as soon as they have put this plan into work. Once they manually pre-chill that line, which is now warm, they're going to let the NASA test director know that it's underway. Stand by for that. This is Artemis Launch Control. It's 8 a.m. Eastern Time here at the Kennedy Space Center in Florida. Good morning, I'm Derrol Nail with NASA Communications with an update. We are in the midst of tanking the core stage of the Space Launch System rocket, set for liftoff today at 2:17 Eastern Time, 2:17 p.m. Eastern Time. This is NASA's moon rocket that is going to send Orion on a flight test around the moon. A little bit less than 38-day mission. This flight test intended to test Orion at lunar return velocity. Get it around the moon, bring it back, test that heat shield, make sure it's safe for humans to use. We are currently working an issue with the liquid hydrogen loading. I'm listening to the launch team now. So there was a leak that developed in the liquid hydrogen supply line at 7:15 this morning. So running behind on loading liquid hydrogen at this point in the operation. We were scheduled to do the engine bleed kickstart. That's on hold. The team currently has a plan to reinitiate the fill of hydrogen. The flow is on the 8-inch quick disconnect, which is opposite a shot we have on the engines. It's in the engine section, but it's the supply line. What you're looking at right now is actually the middle of the rocket, where the GN2, which is liquid nitrogen, or gaseous nitrogen rather, is supplied along with the hydrogen vent line. Here's the engine section. On the opposite side, right where the checkerboard target is the umbilical connection to the rocket, which has a flight side plate and a ground side plate. In the cavity in there, a leak was detected on the 8-inch supply line of liquid hydrogen. I talked to Jeremy Graber, the assistant launch director. He says that they saw a spike in hydrogen gas in there. Now they're reconfiguring the system to minimize the leak and try to get back into hydrogen loading. They allowed the connection to warm up a bit for about a half hour to 40 minutes. And then they are putting right now into effect a strategy to manually begin that hydrogen flow slowly. Try to get that seal to reseat and cure that leak. That's currently in work, and that's the latest. Meanwhile, on the liquid oxygen side, on the liquid oxygen side, they are flowing currently at 32% full. They have slowed down their pumps because of a rule that requires the liquid oxygen to be in a certain proportion to the hydrogen. And you can see the graphic there. The LOX on the left, liquid hydrogen on the right. You can see the graphical representation of the rocket. We're 32% full on LOX. They've slowed down their pumps because of the rule that says you can't get more than 50% LOX in the tank before you've gotten 5% liquid hydrogen in. And I do have confirmation now that 15 minutes ago, the team did start their flow. You can see that represented on the graphic on the right-hand side. The measurement reflecting 2% full on hydrogen, moving slowly and carefully. So we'll continue to monitor the progress here and give you updates as we go along. For now, this is Artemis Launch Control. The core stage LOX team, liquid oxygen team, reporting that they have now satisfied the aft strut constraint. So they are proceeding ahead with full pump speed on the LOX side. As you can see in the graphic there, they're currently 36% filled, while over on the liquid hydrogen side, they are manually filling at a much slower rate to ease into that that transfer, so that in hopes that that QD will hold over on the hydrogen side. Currently, it's at 3%. Again, the aft strut constraint 50% LOX, 5% hydrogen. They're on target to satisfy that constraint. T-minus 5 hours, 29 minutes and counting. Quick update on the flow of propellants into the core stage. The super chilled liquid oxygen back up to full speed, currently 39% full. You can see the capacity, close to 200,000 gallons, and they've got 77,000 gallons in what is a very delicate tanking process. Over on the core stage liquid hydrogen side, currently at 4%. This is in manual fill at the moment. They got a little more than 20,000 gallons in. This tank is most of the core stage, 538,000 gallons. They've got it 4% filled. They saw a leak about an hour ago. So LH2 reporting just now to the NASA test director that their manual configuration for slow fill is going well. That's a good sign. They're going to let that flow for a while before they go back to their auto script, which is essentially software-based flow of the liquid hydrogen, takes over for manual, goes into auto. So we'll await confirmation of that. In the meantime, the rest of the launch team has been configuring the rocket for launch, including the upper stage, what's called the interim cryogenic propulsion stage, preparing that for fill. They've established communications and done other configurations in order to get that ready. And you can see from this shot here, the ICPS, which runs from the beginning of the conical section up to the top of the NASA meatball logo there. That team working on point, but they have had to hold off on a couple of steps in order to wait for the liquid hydrogen to get into fast fill. Of course, you may recall we're supposed to do an engine bleed. That was initially scheduled for just after 8 a.m., so we're running behind on that. But again, the liquid hydrogen team working a plan to reseal a leak at an 8-inch QD on the fill side. This is Artemis Launch Control. 8:30 a.m. Eastern Time, T-minus 5 hours and 15 minutes and counting here at the Kennedy Space Center, getting an update from the LHY team. They're currently discussing some problem solving. They have their liquid hydrogen line in manual fill after a leak developed an hour 15 ago in the 8-inch QD line that supplies the liquid hydrogen. It's just on the opposite side of that checkerboard target on the core stage. Engineers are discussing plans to raise that level to fast fill. I'll have more on that in a second. Stand by. Quarter till 8 a.m. here at the Kennedy Space Center in Florida. You're looking at the venting of gaseous oxygen from the core stage tank midway up the rocket. That's a good sign right there. The liquid oxygen, currently at 56% filled, is going well. Over on the liquid hydrogen side, teams are working to fix a hydrogen leak on the flow there, and they have got the launch director to sign off on a troubleshooting plan, and here's what it is. They are going to do a stop flow on the liquid hydrogen side. they're going to close the vehicle fill and drain valve to keep and protect the hardware. And then they're going to bring up pressure on the ground transfer line with helium and attempt to reseat a QD where the leak is. That QD, it's a quick disconnect. It's on the supply side. If we go down to the engine shot, that's the location where it is. They put pressure on that line in an attempt to try to get that 8-inch QD connection to reseat. They believe that the seal inside the vehicle and ground side plate, which is exactly on the opposite side of the core stage booster there, right there where you see that checkerboard target for tracking purposes. This is the plan that they have in place, again, to try to stop a leak, which they have seen some indication that it continues to leak when they raise the pressure on the liquid hydrogen. That's the latest. Stand by. Hydrogen team updating the NASA test director that they are go to proceed with the raising the pressure to reseat that hydrogen supply line QD. This is Artemis Launch Control at T-minus 4 hours and 45 minutes and counting. You see the Space Launch System rocket on the pad. We are currently in the midst of some troubleshooting to try and stop a hydrogen leak at the cavity between the plates where an 8-inch supply line goes into the tank. The supply line is how the 538,000 gallon hydrogen tank is filled on this rocket. One of the propellants, along with liquid oxygen, it's currently in work. They're going to hold pressure for 5 minutes and see if they can get that seal to reseat. Get that QD in the seal to reseat. As you can see on the left, the liquid oxygen has been continuing to fill, currently at 66%, while the liquid hydrogen is in stop fill while they pressurize this line with helium. Stand by for more. Just got an update from the hydrogen team to the NASA test director. They have completed the pressurizing of the line. Now they're going to slowly restart flow of hydrogen into the tank. Again, they're done with the pressurizing of the line to try to get the QD to reseat and stop the leak that they currently have in a cavity between the plate that holds the ground side umbilicals to the rocket, in between the plate on the ground side and the flight side. We are tracking the progress. T-minus 4 hours and 30 minutes and counting. The hydrogen team has completed the pressurization of the line, and now they are about to begin manually flowing liquid hydrogen through that line again, slowly, to check to see if they were able to get the quick disconnect that's on the other side of the rocket, where all of the lines, the propellant lines, come into the rocket to fill it with liquid oxygen and hydrogen. They're going to start that flow and see if the troubleshooting plan worked. This is the second plan that's been tried. The first one was they let it warm up for a half hour and then flowed propellant back through it to see if that would get it to go. Stand by. Propellant is now flowing. Liquid hydrogen propellant is now flowing through the troubled line with the leak. It's 9:30 a.m. Eastern Time here at the Kennedy Space Center and Launch Complex 39B. The Space Launch System and Orion spacecraft on the pad have an update about the troubleshooting plan. It did not work. The second troubleshooting plan to seal a hydrogen leak at an 8-inch line that feeds the propellant into the rocket. The troubleshooting effort, as reported by the hydrogen team, they said they started slowly bringing liquid into the tank, and gradually, as they started to raise that pressure, they saw the leak detector go up above 4%. So they've backed it off a little bit, and now are going to look for another plan to try and get this leak to seal. Engineers now headed over to the anomaly loop. It's a channel where the engineers, the launch engineers and Boeing engineers, chief engineer, will all be discussing a next plan, a plan C. They've been in some preliminary discussions about it, so they've already kind of talked it a bit, but now they're discussing it now, and we'll tune in and find out more. Again, just to recap, a little more than 2 hours ago, a leak developed in the supply side, the 8-inch line, liquid hydrogen line, while attempting to transfer from slow fill to fast fill to load hydrogen into this rocket. And we've been going through a number of troubleshooting steps. The first was letting the connection warm up for 30 minutes and then manually starting back a slow fill. The second troubleshooting was pressurizing the line with helium to try to get it to reseat. Neither troubleshooting effort was successful. And so now we're awaiting next steps. This is Artemis Launch Control. Quick update. Engineers still discussing another troubleshooting plan. Again, engineers discussing another troubleshooting plan to try and fix a leak in the liquid hydrogen side line that leads into a cavity with the two connection plates on either side, on the vehicle side and the ground side. Stand by for more. Got an update on the engineering discussion regarding what to do next about the hydrogen leak at the 8-inch quick disconnect cavity where the 8-inch hydrogen line goes into the rocket. Engineers discussed it thoroughly, discussed a couple of options, and where they landed is with trying troubleshooting plan A, the first troubleshooting plan that they did. This was the one where they stop the flow of hydrogen and allow the connection to warm up for 30 minutes and then manually start back with a flow. Now, the good news for the liquid hydrogen team is they had already stopped flow, so the connection was warming up for the past 15 minutes. So they only have another 15 minutes to go from this point in putting in this most recent troubleshooting plan, which is a plan that they are knowledgeable about and are experienced with. It is the go-to plan when they are looking to try to reseat that bullnose connector into the seal at the connection point for the 8-inch hydrogen line. So it is in work. They got the go from the launch director to give this another shot. Again, they're going to warm up the connection and then hit it with some cryos and see if that shakes it enough to get it to reseat that bullnose connector into that seal. Over on the liquid oxygen side, we are into topping as of right now. Just heard an update from the cryo team. You can see on your screen we're at 99%. almost full. Topping is a stage where it slowly now automatically fills to the 100% level, and then once we get to 100%, then it will go into what's called a replenish mode, which is replacing what is lost from boil off. The tank is boiling the entire time that it's filled and loses an amount of propellant. Replenish puts it back in. All right, we're standing by to see how this most recent, this newest troubleshooting plan goes. This is Artemis Launch Control. And with the core stage at 99%, you can see the venting of gaseous oxygen is in full flow 2/3 of the way up the rocket. You're looking at the nominal venting of gaseous oxygen out of the core stage. Quick update on the situation out here, the troubleshooting that the launch team is currently in the midst of to try to get this leak to seal. They have completed the warm-up and are now standing by to manually resume hydrogen flow through the line where they have seen the hydrogen leak. At the same time, the launch team that's managing the upper stage is going to start doing their purge sequences for the ICPS, the interim cryogenic propulsion stage. This is at the top of the rocket. They purge out those volumes in there and purge out the lines with nitrogen over on the liquid oxygen side and helium on the liquid hydrogen side. Purge out those lines. This is they're going to do this so that they can catch up on the timeline, which has fallen behind due to the liquid hydrogen leak. So the team doing what it can to preserve this launch window, and then we're also monitoring this troubleshooting as well. We're at T-minus 3 hours, 34 minutes and counting. This is Artemis Launch Control. And one more update just came in. The core stage is now officially in replenish. The core stage is now officially in replenish for the liquid oxygen tank. And you can see that venting from this shot right here and from this shot, fully venting out of the core stage at the top. Liquid oxygen is good to go. In replenish, still working troubleshooting over on the hydrogen side, which is currently sitting around 9% full. Again, the team getting ready to manually start flow. LH2 has resumed flow slowly into the tank. Engineers opening that valve manually to allow that liquid hydrogen to flow into the tank. Again, checking to see if the latest troubleshooting, which was also the first troubleshooting plan, but trying it a second time to see if that's going to result in reseating a bullnose connection on an 8-inch hydrogen line into a seal that currently has a hydrogen leak. The liquid hydrogen team keeping the test director informed of all updates, and we are passing them along to you in real time. This is Artemis Launch Control. An update on the troubleshooting. The second attempt at a warm-up of the connection with the hydrogen line did not work. Again, the second attempt to warm up that connection for a half hour and then hit it with cryos in order to get the bullnose connector to reseat in the seal did not work. LHY, the liquid hydrogen team, reporting to the NASA test director that as soon as they resumed flow, when they added any pressure at all, they saw the leak return. So that's the third troubleshooting attempt, two of them the same, the first and the third. Team now is discussing next steps. This is Artemis Launch Control. This is Artemis Launch Control. The engineering team is updating the NASA test director about the situation with the hydrogen leak. We should have an update shortly. This is Artemis Launch Control. The launch team has, the launch team has presented a recommendation of no-go for launch to the NASA test director and launch director. We are currently waiting a decision by launch director Charlie Blackwell Thompson. Stand by for that. Once again, the launch team has recommended a no-go condition for launch today to Launch Director Charlie Blackwell Thompson. She is conferring with Mike Serafin from the mission management team, expecting a decision shortly. This is Artemis Launch Control. Launch Director Charlie Blackwell Thompson addressing her team just a few minutes ago. Says she has received their no-go recommendation but wants to hold off. Some additional thoughts and conversations are being developed about the situation and where the rocket stands, and said she will revisit it momentarily. Currently, we're in acceptable condition to hold. The launch team has the liquid oxygen in a stop flow configuration, safe at this time, and just awaiting a final a decision from the launch director at this time. This is Artemis Launch Control. This is Artemis Launch Control. Launch Director Charlie Blackwell Thompson just called a scrub for the launch attempt today, the second launch attempt. Again, Launch Director Charlie Blackwell Thompson calling a scrub for the day here at the Kennedy Space Center Launch Complex 39B. The team now going into the cutoff procedure after being unable to resolve a hydrogen leak. The vehicle is safe. NASA Test Director Jeff Spaulding now putting the team into a configuration to drain the propellants from the tank. Liquid oxygen reached a 100% state, and so the priority will be given to draining that tank. And currently they are underway. Again, we have a scrub for the day, a cutoff of the launch attempt of Artemis One. We're working on a post-scrub interview, so please stand by for that. This is Artemis Launch Control. This is Artemis Launch Control. Again, the launch attempt, the second launch attempt of the Space Launch System and Orion spacecraft has been scrubbed. Launch Director Charlie Blackwell Thompson making the decision a little less than 10 minutes ago. Her team is now working to detank the rocket. Liquid oxygen reached 100% filled. Core stage only made it to roughly 11% before a hydrogen leak was detected. That leak detected at 7:15 a.m. Eastern Time. The team is focused and working diligently on the drain conditions. since there was a leak in this line, the supply line, it is also the drain line. And so launch team taking care to make sure that they work that procedure, taking that into consideration, I should say. This is Artemis Launch Control. This is Artemis Launch Control. The launch director waved off today's attempt at launching at approximately 11:17 a.m. Eastern Time. The launch team ran into a liquid hydrogen leak while loading propellant into the core stage of the Space Launch System rocket. There were multiple troubleshooting efforts that were made to try to get the leak to stop and reseal the connection from the quick disconnect of the liquid hydrogen line. This is where the liquid hydrogen is fed into the rocket. Unfortunately, those attempts to troubleshoot it did not succeed. Engineers are still continuing to gather data, but also deconfiguring the rocket and detanking at this moment the liquid oxygen tank. It's currently down to 90% filled. Due to the aft strut constraint, they're going to drain that tank first, while the core stage liquid hydrogen tank is held at its current level of 11%. The aft strut constraint requires the team to have at least 50% filled liquid oxygen to over 5% liquid hydrogen. This is Artemis Launch Control.
Thank you.